Welcome back, ladies. Oh, and gentlemen. Yes, you're welcome as well. Welcome back. Greg Silverman here, Chief Investment Officer. Another session of Come Learn With Me. Many folks say, well, Greg, we found some of these videos interesting. We learned some interesting information, but how do we kind of get more involved in your program? And I say to them, funny you should ask. Please wait till the end of this video where we'll flash up a little URL and you can follow us to our more business side, our bow tie side. All right, this article was found to be popular amongst our readers. So thank you very much. Let's have a look. Electricity on the moon. NASA starts accepting proposals for establishing lunar nuclear power systems by 2030. Okay. Well, you remember that we do a uranium and nuclear I'll call it a sub-learn with me. Not a subreddit, but a sub-learn with me. Where we've been doing a lot of research work in the uranium space because we're quite active there. All right, let's see. Artist concept of new fission power system on lunar surface. Remember fusion versus fission? No, that's not. Okay, that's cool. Electricity has revolutionized the world like nothing ever has, and it's impossible for humanity to imagine a life on Earth without it. Now, what if we could generate electricity in space? Can it revolutionize space travel? The US Space Agency, NASA, has now announced its decision to put a durable, high-power, sun-independent fission reactor on the moon positively before 2030. So by any chance, if you've been sketching the blueprints for a portable nuclear fission power plant, this is your time to shine. The only condition is that NASA should be able to carry it to the moon in a 12-foot long by 18-foot wide rocket. NASA collaborates with the Department of Energy, Idaho National Laboratory, to invest in this multi-billion-dollar project. Whoops. Alert. Okay. Even though humanity will visit the moon after nearly 50-year hiatus by the Artemis mission, one can say that it is still an incredibly bold statement to make, considering how the group's plan to make this work remains a gray area. On November 19th, the INL released a statement saying they are seeking industry partners to design nuclear power systems for lunar applications. This request for reactor design on behalf of NASA and a contractor of the DOE is open until February 19th, 2020. Why a nuclear power plant of all things? Yes. The US hopes to have the first long-term presence on the moon in the near future. To succeed, they will most likely need a power source. Wind or hydro power sources are impossible because of, well, the absence of both on the moon. Fossil fuels are far-fetched too because of how expensive it would be to carry them off to them. In comparison, the solar power is a lot more plausible, but again, it could probably only provide energy for the few hours that the panels are exposed to sunlight. So the only option remains nuclear. Well, this is the exact same argument for having more nuclear on Earth. Right? Rings a bell. Plentiful energy will be key to future space exploration. I expect fission surface power systems to greatly benefit our plans for power architecture for the moon and Mars, and even drive innovation for us uses here on Earth, said Jim Reuter, an associate administrator for NASA's Space Technology Mission Directorate. The specifics. And NASA plans to employ specially constructed small modular reactors, SMRs, to supply consistent power. Why did I raise my finger? Because we've been reading about SMRs in previous uranium articles, and we've come to be a little bit of experts, should I say, armchair experts, to supply consistent power in any environment, just like they do on the ground. However, the units will have to be designed to withstand the most adverse of environmental conditions. According to the press release, the proposed reactor needs to be a uranium-powered fission reactor capable of splitting heavy atomic nuclei into lighter nuclei, releasing energy as a byproduct. The reactor must weigh no more than 6,000 kilograms and be small enough to fit into the rocket, 12 by 18. Get out your sketching pad, guys. The reactor will be built on Earth and then launched to the moon, where it will be required to generate 40 kilowatts of continuous electricity power for 10 years. Here's a question for you. Why not have a 3D printer that can print something like this in space instead of having to assemble it and blast it off? Just wondering. The reactor must include temperature controls as well as to keep the device cool. Lastly, it must have structural integrity to hold out against its launch from Earth and landing on the moon. The big picture. The bigger picture. It would be reasonable to question NASA's decision to dive into this decade-long project, especially because the US will be spending several $billions on it. According to reports, scientists at the Beijing Research Institute of Uranium Geology were conducting rather peculiar experiments on moon rock samples, and the tests indicated that the superpower was probably trying to see if they could build a nuclear reactor power plant on the moon. There you go. And in honor of my Chinese readers, counterparts, that, my friends, is the wonderful city of Beijing, sunrise in Beijing. If this is true, it certainly explains why the US would want to get a head start on such a lucrative expedition. Anyhow, irrespective of the motive, if NASA pulled this off, it would be incredible and mean that we could take more such technologies to the red planet. All right, guys, you want to know more about our investment program in nuclear uranium, follow this URL over here and come check us out. And I hope you like this. Interesting indeed. Nuclear power, and then China attempts to do the same. So a lot of cross channels here. Hope you enjoyed this, guys. Like and subscribe to our channel. Greg Silverman out for now.